Ugi reaction. First, class, come on, say hi to Mr. Ozzy. I'd like to see you at the class!
Hi, Ozzy.
Good student. Very good student! Okay. So today we're going to be learning about the Ugi four-component condensation reaction. Now, it is between an aldehyde and an amine. Pay attention! It's between an aldehyde, an amine, carboxylic acid, and an isocyanide. Okay? So you start with your amine and your aldehyde, and what will happen is it forms an amine. Now, the amine is spelled with an I, not an A, an I. Amine. Now, the amine, it reacts with a carboxylic acid where the nitrogen will get protonated by the carboxylic acid proton to form this species with a positive charge on the nitrogen. Now, I heard something in the audience, and I'm not sure what it was. So now you have this negative species, and so now we will move on to the second part of the reaction. Okay? So your isocyanide will then, with the negative charge, attack the alpha carbon, the acidic carbon, keeping that in mind. And by doing this, the electrons in the bond will go to the nitrogen to get rid of the positive charge. Okay, class? Cool. Cool. But it's important to know that it happens because this species from which was deprotonated causes it. So the oxygen acts as the nucleophile, and attacks the carbon, and yes, more so, the oxygen attacks that nitrogen, which bond does and take a wave. And so now you have this beautiful intermediate. And what happens is beautiful. The nitrogen lone pair will attack the carbon, and what will happen is the bond breaks, reforms with this carbon. The double bond between the carbon and the nitrogen attacks an acidic carbon from the carboxylic acid species in the solution, and the nitrogen gets deprotonated yet again in order to form your four-component Ugi reaction. And this is the mechanism. So, do I have any questions? I would like to see after. I am not eating. I am yoga.
Sorry, sir.
You better be.
And Ugi reported that isocyanides undergo a four-component reaction in the presence of an amine, aldehyde, or ketone, and a nucleophile to provide a single condensation product. Most commonly used nucleophiles are carboxylic acids, but hydrozoic acid, cyanates, thiocyanates, carbonic acid, monoesters, salts of secondary amines, water, hydrogen sulfide, and hydrogen selenide can also be used. One of the earliest and most important applications of the Ugi reaction is peptide coupling and alpha amino acid synthesis.
The hydroxide from a strong base such as NaOH attaches to the carbon of the aldehyde. The addition of a hydroxide causes the electrons from the double bond to move to the oxygen, making it negatively charged. Another hydroxide comes in and removes the hydrogen from the alcohol group, leaving a negatively charged oxygen. A second aldehyde reacts with the intermediate and transfers the intermediate's hydride over to the new aldehyde. The hydride shift causes a single bonded oxygen to form on the new aldehyde. The hydride shift also causes a double bonded oxygen to form on the intermediate, creating a carboxylate ion. This allows there to be resonance between the two oxygens. The electrons from the negatively charged oxygen take a hydride from a water molecule. The final products are a primary alcohol and a carboxylate ion that can also be protonated by the water to produce a carboxylic acid. The Cannizzaro reaction was first discovered in 1853 by Stanislao Cannizzaro. The reaction requires two aldehyde reactants that cannot be transformed into enols and that lack an alpha hydrogen. The aldehydes are dissolved in a concentrated strong base such as sodium hydroxide. The resulting product is a primary alcohol and a carboxylic acid. The Cannizzaro reaction is a redox disproportionated reaction. This means that a molecule is reduced and oxidized simultaneously to form two different products. However, unless an alpha ketoaldehyde is used, the yield of this reaction is very low, producing only 50-50 alcohol and carboxylic acid. Thus, this reaction has little synthetic use since there are other redox agents that are able to produce the same products but with higher yield.
Please don't. Weird. Look at that. What's an O? I mean a negative. Woohoo!
Now you shall not get me this one!
Because it's hard to see.
Tell me when you're like,
Recording.
It's already recording. It's even worse. Oh my god. It's gonna.
Biatch.